Hi everybody. So in today's video, I'm going to be conducting an anomaly test and seeing how it affects prices on Bitcoin's level 2 order book. So let me go ahead and load import WebSocket, import JSON, um, and then let me establish my data feeds. So this will be actually, yeah, I should do threading. So import threading. So this will be class socket feed of threading.thread, and then I'll initialize the constructor self, and then it's going to be threading.thread.init self, and then I will do self.url equals wss feed.exchange.coinbase.com, and then self dot. So I'm just going to make the default ticker equal to BTC USD. So it'll be self.ticker equals ticker. Um, I believe I have all I need over there. Oh wait, no, I need self.bids equals empty dictionary, self.asks equals empty dictionary. So I will come over here. Oh, actually, no, let me do this. I'll do def run self. So this is going to be con equals websocket.create connection self.url. Message is going to be type subscribe. Um, Product IDs is just going to be self.ticker, and then channels is just going to be level 2 underscore batch, and then I'm going to do con.send json.dumps message, and then while true, the response equals json.loads con.receive, and then I'll print response. So I'll come over here and do feed equals socket feed, and then I'll do feed.start and feed.join. So let me come over here to the terminal, and now I'm going to run python anomaly.py. Okay, I can't stop this. All right, that was intense. So then I believe it'll be if type in response.keys, if response type equals snapshot. Let me go ahead and print response. Um, so now run it. Okay, good. So the order book was able to run through. So now it's going to be easier. So I will do, let's see, this will be self.bids equals I, J. Well, let me make a float of I, float of J for I, J in response bids, and then self.asks equals float of I, float of J for I, J in response asks. And then it's going to be if response type equals level 2 update, I will do for side price volume in response changes. Let me just go ahead and print this out, side price, just to like make sure that it's working. So I'll open a new terminal, python anomaly.py. Okay, so that works. So then what I'm going to do is price volume equals float of price, float of volume, and now if side equals buy, if volume equals 0, if price in self.bids.keys, this is going to be delete self.bids of price, else it's going to be self.bids bids of price equals volume. And then if it's a sell order, it's going to be if volume equals 0 again. If price in self.asks.keys, delete self.asks of price, um, else self.asks of price equals volume. And now that we have this, I can come over here and do self.sync equals false. But once I put in the bids and asks, it's going to be self.sync equals true. Okay, so now that I got that, I need to sort of extract a certain amount of depth from it. So this is going to be def extraction. So it's going to be self and then depth. I'll set depth equal to 5 on default. I will change these later, but what it's going to do is I'm going to do bids equals self dot bids, rather self dot bids dot items, and then wait, do I have numpy over here? Oh yeah, let me go ahead and import numpy. So import numpy as np. Um, okay, so bids dot key, list sorted self dot bids dot items, and then it'll be up to, actually I need to do reverse equals true, and then pull it to the depth, or rather wait, negative depth. Yeah, so it's doing it from the highest bid to the lowest bid. Or no, I had it right before. It's supposed to be depth. So yeah, highest bid to lowest bid. Asks is going to be list sorted self dot asks dot items, but it's not going to be reversed. So then it's going to be to depth. And then mid market is going to equal bids of 0 plus asks of 0, and then it's going to be 0.5 times these. So we got the mid market. Let's see, what do I want to extract? I'm trying to think right now. It's like I need to extract the prices and volumes. So this will be um yeah, I think I have to turn these into NumPy arrays. Let's see. So or I can just do it here. I got the mid-market price. I'll do bids equals NumPy array of bids. Asks equals NumPy array of asks. Um, and then wait, actually, I could probably speed this up much faster. I'll just write, can you make the function extraction, or no, I don't need to use AI for this. What am I thinking? Or I'll ask it how to sort NumPy array, just so I could have like an easier, oh, it's just NumPy.sort. Okay, so let me back out of all of this. Or actually, no, what am I doing? These have to be in a list. They can't just directly convert. All right, yeah, so scratch whatever I wrote in there. That's just a waste of time. My bad, y'all. Um, so what I'm gonna do is bid price, bid volume equals bids 0, bids 1, ask price, ask volume is asks 0, asks 1. So now these need to be normalized differently. So what I'm going to be pulling is what I'm going to feed into the autoencoder. So I'm going to do, let's see, feed equals, wait, I need to normalize these. So it's going to be BP equals, okay, so it's good that I have the mid market between these because this is going to be BP equals BP minus mid divided by mid, and AP is going to be AP minus mid divided by mid, and then BV is going to equal BV divided by the sum of BV. AV is going to equal AV divided by the sum of AV. So then feed equals BP.toList plus BV.toList. Or should I separate the volumes? Yeah, I should separate the volume. Yeah, so BP.toList plus AP.toList plus BV.toList plus AV.toList. And then I'm going to return feed and mid market because all I need is just the inputs. So these are all normalized. So let me now come over here and do while true. If feed.sync equals true, I will do feed. So I'll call this inputs and price equals feed.extraction. And I want it to withdraw several depths. So I will come over here and do depths is going to equal 5, 10, 15, 20, 25, 30, 35, and 40. So these are going to take several inputs. So actually what I'm going to do is come over here and actually, hold on. Maybe I should set up PyTorch now. Yeah, I should set up the autoencoder now. So I will separate this and I'll do import torch.nn as nn, and import torch.optim as optim. And then I will do class autoencoder, which inherits the neural network, so module, and then initialize the constructor, and then pass inputs. So then this will be self.encoder equals nn.sequential. Oh wait, I need to initialize the constructor, so it's going to be super autoencoder self.init. So then now the encoder is going to be nn.linear of inputs to 30, nn.sigmoid, oh no, not sigmoid, relu, and then nn.linear of 30 to 15, and then nn.relu, and then it's going to be nn.linear of 15 to 10. So that's the encoder. So now I'll do self.decoder equals nn.sequential of, I'm trying to think if I should put a relu underneath linear. No, I don't think I need to. So this will be nn.linear of 10 to 15, nn.relu, and then nn.linear of 15 to 30, nn.relu, and then nn.linear of 30 to output inputs. Yeah, so I need a comma there. Okay, so I got commas all over here, got commas all over here. So now I'll do the forward propagation. So def forward of self and x, return self.decoder of self.encoder of x. Um, so now that that's done, I have to define several ones, so I will do, I'll call these auto encoders, or I'll just call it nnet. I mean, there are neural networks, so this is going to be depth, and then auto. Let's see, so it would be four times that, so it'll be auto encoder of depth times four for depth in depths. Okay, so now I can come over here and do for depth in depths. Uh, I could do depth equals depth, and then it's going to be nnet of depth. Well, okay, I do need the optimizer. So yeah, let me go ahead and do this. So I'll do learning rate equals 0.001. I will do epochs equals 50. And then criterion, or no, I'll do optimizer. Wait, hold on. Oh, they all have their own. Yeah, so I will do nnet. No, I'll do this as models equals depth for depth in depths. So this will end up being loss, which is going to be neural network.mse loss. I'll keep the learning rate constant, or whatever's the default in it. But what I'm gonna do is loss is gonna help me compute the anomaly. Optimizer is gonna be shit. I guess each model. So optimizer is gonna be optim.atom of nnet of depth dot parameters. And I'm going to keep the learning rate constant in it. So now what I'm going to do is, so for each depth, yeah, I guess I can do it in loss. Okay, this is a little tricky. So nnet dot depth, so it gets the autoencoder. Um, or actually, oh, maybe I should do for epoch in range epochs. Wait, did I already delete epochs? Okay. Epochs is going to equal 50. Let me separate these. Um, so epochs is 50. So it's going to be output, I'll call it out equals, so it's going to be nnet of depth inputs. Oh, wait a minute. No, I have to convert inputs to a PyTorch tensor. So this is going to be in x equals torch.tensor of inputs, and dtype equals torch.float 32. So I'll call this in x, and then it's going to be loss equals models of depth of loss. So that's criterion. So it's going to be out and inputs, and then it's going to be models of depth optimizer dot backward, no, zero gradient, and it's going to be models of depth loss dot backward, and then models of depth optimizer dot step. And now that we have that, this will be, oh wait, I need to, so I guess what I'll do, so I have loss over here. I will come to the end of this and type an anomaly, and I will set it equal to 0. So then this will be, so I guess it'll reset to 0 here. So it'll be models of depth of anomaly equals 0. But over here, it's going to be models of depth of anomaly equals plus equals loss dot item. So now that I got all of that, I will do, let's see. So I have the price. Well, the price is going to remain constant. So I guess I could just call it outside the loop. So what I could do is, because this is just going to be a visual of the anomalies for the different depths. Um, so I probably should come up over here and import matplotlib.pyplot as PLT. And I'll define my figure up here. So fig equals plt.figure, ax equals fig.add subplot 111. So I believe I could come down here and do so feed.sync. So this will be ax.cla. Oh wait, I need two plots, so ay.cla as well. So 1, 2, 1, ay equals fig.add subplot 1, 2, 2. So I need to store the prices. Let's see. Yeah, price in here. So I will do store prices equals empty dictionary. So outside of depth, I could just come here and do store prices dot append price. Okay, but let's say I don't want to have like 1,000 prices on here. What I'm gonna do is do if the length of store prices is greater than 40, delete store prices of 0. Um, so then this is going to be ax.bar of depths and um, the anomalies. So it's going to be models of depth for depth in depths. Okay. And then it's going to be 1.0, 1.0 color equals cyan. And then ay dot plot store prices color equals red and plt.pause 0.01. So now I'm going to come here and do plt.show. So let's wait, let me add some titles. So ax.set title of anomaly, ay.set title of Bitcoin price. So Now up here, Python anomaly.py. I'm going to be so surprised if it doesn't have any errors in it. Okay, it's loading. Cannot multiply a sequence by a non-type float. Oh, right. Okay, so it's threaded so it doesn't shut off. So I have to come back over here. So yeah, okay, so I come over here and do mid equals BP of 0 plus AP of 0 because I didn't sort them. It's going from highest bid to lowest. So that's the first element. So it's decreasing. So this will end up being 0.5 times BP times AP. So yeah, now we got the mids. So I'm going to run anomaly again. MSE loss object has no attribute backward. Okay, let me go back to the training. Oh, what was wrong about it? I thought that was the... Oh, okay. It's actually supposed to be loss dot backward. Okay. Yeah, that makes sense. So, new terminal, Python anomaly.py. Is there going to be another error in it? Yeah, okay. Another error was actually with the plot. So that's referring to like everything. Um, so I should have done depth anomaly. Yeah, so I think that was the last error in this. So shit, I'm gonna go to new terminal and then do Python anomaly.py again. So yeah, that should have taken care of all the errors. So let's see, oh wow. So we can see there's huge anomalies at 5 depth, but they're not so much. Okay, so the price went up. Wow, this is cool using like an autoencoder to like see like real-time price updates on Bitcoin. Oh, it dropped. I'm trying to make sense of, is there sort of a correlation with this? It seems as though, yeah, so it's dropping right now because the first two levels of depth in the autoencoder are high. But let's see if it goes up. Oh, it's still going down. Um, yeah, well, this so there's a large amount of suspicious activity going on at the 5 depth, which I guess makes sense. That's where everybody's like trying to bid out against everybody. Um, yeah, it just seems to be tanking down, so they're trying to catch up. So if we see, I'm guessing if we see a huge anomaly at 40 depth, it may be a reverse signal back up. Or I guess you just can't correlate anomaly with price. It came back up, so there are more activity going up. From the looks of it, though, there may be just trying to make it drop right now. But yeah, that's about it for this video. This is the Bitcoin anomaly detector. There's lots of like strange activity going on in the book. So it's plotting all of that here. So yeah, I thank you all for watching this video. I'm gonna keep coming out with more and more good quant content, so stay tuned and peace out.